Good morning. The following session, Zoom session, is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I will respond as soon as I can. Okay, so today we're going to start off with some questions that one of you emailed me that you wanted to look at. So this is from section 6.2, yesterday's homework. And so let's take a look at problem number 23, which says 12n to the 5th power minus 72n to the 4th power minus 60n cubed. All right, so the greatest common factor is 12n cubed, and that leaves behind n squared minus 6n minus 5. Okay, so we're going to pick it up there. Give me just a second here to get things written orderly. So now we're going to go back here, and we've got this so far. All right, now let's take a look at what's in the parentheses. N squared minus 6n minus 5. It's in descending powers. It has a leading coefficient of a 1. There's no greatest common factor. We already took that out. So the product would be -5 and the sum would be -6. Okay, well, to get a negative product, we'd have to have a positive and a negative. So we could have like 5 and -1 or -5 and 1. I think those are the only two possibilities, but neither one of those give us a sum of -6. So basically we're done. Now, a question that came in yesterday is somebody said, well, they wrote prime and it wasn't prime. This is not prime. This part of it won't factor any further, but our original trinomial, we were able to take out a greatest common factor. It's only prime if there's nothing you can do with it from the very beginning, okay? This piece of it doesn't factor any further, but the whole thing isn't prime. For instance, let's say I had 10, okay? 10 is 2 times 5. Is 10 prime? No, it's not. 5 doesn't factor any further, but I did factor the 10 somewhat. So like here, I've got this factor coming out, that factor remaining, so it's not prime, but this doesn't factor any further. Okay, I think I've beat that dead horse enough. Now we're going to take a look at problem 31 from the same assignment. And this will give us a good chance to review properties of exponents. For those of you that need a full review, this is back in chapter 5.2. All right, but we've got a to the 6th power times a to the -3rd power over a to the 3rd power times a to the 0 power. So let's take a look at that. Well, first of all, let's look at the numerator, okay? When you're multiplying two powers with the same base, you add the exponents. Well, this would be a to the 6 plus -3 power, which would be a cubed. So the numerator becomes a cubed. Well, in the denominator, the same thing. Multiplying two powers with the same base, you would add the exponents. 3 plus 0 is 0, or excuse me, is 3, so you get a cubed. Also, I want to remind you that a to the 0 power is equal to the number 1. So I could either just use this rule and write it as, whoops, come on, eraser, don't fail me now. I could write it as a cubed or as a cubed times 1. In either case, I ultimately get a cubed because a cubed times 1 is a cubed. And then finally, dividing two powers with the same base, you subtract the bottom exponent from the top. So this would be a to the 0 power, which is 1. Also, a number divided by itself reduces down to 1 over 1, unless it's 0 over 0. But anyway we go, we get a final answer of 1. Do you have any questions about this problem before we go on? All right. Do you have any questions about any other problems from last night's homework before we go on? Okay, then we'll go on. And so we're going to take a look at section 6.3, and I'm going to say part 1. We're going to spend 2 days on this. There are 2 different methods of factoring certain trinomials, and I want to take a day on each one. And then ultimately, you can choose either method you like, but I want to expose you to both methods. The first method that we're going to look at typically is called, well, let's see, we'll say the grouping method, okay? I call it the ABCPS method, and I will explain that thoroughly as we go, but it's the same method, and your textbook has both methods that we're going to cover discussed. Anyway, we're going to look at the grouping method. Now, when do we use this? We use this when we have a trinomial that after it's been put in standard form and after any greatest common factor has been removed from everything, whatever's left there, if that trinomial has a leading coefficient other than a 1. If it has a 1, then what we looked at yesterday, 6.2, that's how we deal with it. But if it has something else, we have to deal with a more complicated process. All right. So the first problem we're going to look at, this is 3x squared plus 4x plus 1. Oh, just a side note. If any of you have the hard copy of the textbook and you're curious, all these problems I'm doing as examples, I'm getting them out of the textbook. So if anybody wants and says, hey, where is that in the book? I'll give you the page number and the problem if you want, but otherwise I won't. So that's up to you. Okay. Anyway, so here we have a trinomial, okay? It's in standard form, descending powers of the variable, x squared, then x, then no x at all. There's no greatest common factor that I can remove. All right. Now, I want to think of this as ax squared plus bx plus c. So a, b, and c are the coefficients of the 3 terms once they're put in descending order. Okay. So a is 3, b is 4, and c is 1. Any question where I got those numbers from? All right. The next thing I'm going to do is form the product of a times c. So in this case, the product would equal 3. Okay. So I'm going to take a times c to form my product. The sum is going to be equal to b. So the sum would equal 4. So similar to yesterday's method, we're finding a product and a sum. But now the product is the first coefficient times the last coefficient, not just the last coefficient. So this is similar, but not exactly the same. Okay. So again, any questions where I got p equals 3 and s equals 4? So now I'm looking for a pair of 2 numbers whose product is 3 and whose sum is 4. Since the product is positive, it has to be a positive times a positive or a negative times a negative. But since the sum is positive, it has to be 2 positive factors. So 3 and 1. 3 times 1 is 3, 3 plus 1 is 4. Okay. Now, we're going to take these two numbers and we're going to take the original trinomial. We're going to use the first term the same and the last term the same. Hello. But we're going to take the middle term and we're going to split it up into two terms that have these two numbers as their coefficients. So 4x becomes 3x plus 1x. Now, technically, I don't need to put this 1 in front of the x. I could have just written plus x, but I'm emphasizing where things are coming from. So we're taking that and splitting it up into that using these two numbers as the coefficients. Okay, now this seems kind of complicated, but once you get used to it, it's the same every time, so it really isn't that bad. Now I have 4 terms. We are now going to use factoring by grouping that we did back in section 6.1. Okay, so I'm going to split this up into 2 groups of 2. The greatest common factor of the first 2 terms is 3x. The leftovers are x plus 1. So over here, the leftovers are x plus 1, and I need a plus 1 outside. So I get x plus 1, 3x plus 1. Now, if I'm losing you from here to here, go back to 6.1 and revisit that whole idea of grouping. Because this whole process, what we do, we find these 2 numbers, we split the middle term, we create 4 terms, we use factoring by grouping. Okay. The only part of this problem that should be tricky is finding the 2 numbers. All right. Any questions about what I did? Okay. New problem coming up. Let's see here. 2b squared plus 7b plus 3. So we have a trinomial in standard form. There's no greatest common factor that I can take out. The leading coefficient is positive. If it was negative, I'd factor out a -1. We talked about that. But the leading coefficient is not a 1 either, so I'm going to use what I'm calling this ABCPS method, or the grouping method. All right, so A is 2, B is 7, and C is 3. The product is A times C, which is 6, and the sum is B, which is 7. Again, any questions where I'm getting the 6 and the 7? All right, so now I'm looking for a pair of numbers whose product is 6 and whose sum is 7. To get a positive product, the signs have to both be positive or both be negative. But to get a positive sum, you can't add 2 negative numbers and get a positive sum. So we're looking for 2 positive numbers, 6 and 1, 3. Oh, 6 and 1, that has a product of 6 and a sum of 7. So I really didn't need to go any further. So now I'm going to take this and split it up. 2b squared plus 6b plus 1b plus 3. So again, I use those to split that middle term. Any questions? Factoring by grouping. The greatest common factor of the first 2 terms is 2b. The leftovers are b plus 3. On the right side, the leftovers are b plus 3. I need a plus 1 outside to make it work. The common factor here is b plus 3, leftovers 2b plus 1. Check your work. Well, let's see. We get 2b squared plus b plus 6b plus 3, 2b squared plus 7b plus 3. It matches. So here is the correct answer. Again, Any questions? All right, we'll continue on then. 15a squared minus 28a plus 5. This is a trinomial. It's in standard form. There's no greatest common factor we can take out. There's no negative to factor out. The leading coefficient is not a 1, so we'll use the ABCPS or the grouping method. A is 15, B is negative 28, C is 5. The product is A times C, which is 75. The sum is B, which is negative 28. Again, as I'm going along here, if you're getting lost, please stop me, okay? To get a positive product, we have to have two factors that are both positive or both negative. But to get a sum that's negative, they'd have to both be negative. So there's no point in us exploring numbers like positive 75 and 1 or positive 15 and positive 5. They've got to both be negative. So let's see, negative 75 and negative 1. Well, that would give us a sum of negative 76. That's not right. How about, let's see, I could negative 25 and negative 3. Negative 15 and oh, wait a minute. That gives us a sum of negative 28, doesn't it? So once I find it, I don't need to keep going. Okay, so now I've got 15a squared minus 25a minus 3a plus 5. I'm going to use factoring by grouping. So let's see here, I'm going to get 5a and then 3a minus 5. And over here, 3a minus 5. Oh, I'm going to have to factor out a negative 1 over here to get 3a minus 5. So then my final answer is 3a minus 5 times 5a minus 1. Any questions there? Now, a question that students ask, so I'll just ask it ahead of time. Does it matter which order I put those two? What if I wrote 15a squared minus 3a minus 25a plus 5? What would that look like? Would that change things? So let's do that. 15a squared minus 3a minus 25a, and then what was it? Plus 5. Plus 5. All right, so let's take those two terms in the middle and switch them around. Well, using factoring by grouping, let's see, here I'd take out a, oops, slow down. And then my eraser doesn't always work. Boy, I guess. There we go. I take out a 3a and I get a 5a minus 1 and a 5a minus 1. And a minus 5, which gives me a 5a minus 1, 3a minus 5. So we get that answer. Well, can you see that that's the same answer as we had here? It's just that the factors are commuted, which is the same answer. So given these two numbers, when you split it up, you can write it that way, or you can write it switched around, as long as you've got the correct signs with them, and you get the same ultimate result. Okay, let's take a look at this problem. 4b squared plus 15bc minus 4c squared. Well, we have a trinomial. It is in standard form in terms of b. We have b squared, then b, then no b at all. There's c's in there, but we can deal with that, okay? There's no greatest common factor. The leading coefficient isn't a 1, so we're going to use the ABCPS. Now, be careful. The A, B, C that I'm referring to there are not the same as the B and the C variables in the problem, okay? The stuff I'm referring to over on that column are the coefficients. So we've got to be careful there. All right. So A is 4, B is 15, and C is -4. The product would be -16, and the sum would be 15. All righty. The sum is negative. Well, two positives multiplied give us a positive. Two negatives multiplied give us a positive. So we've got to have one of each. We've got to have a positive and a negative. But when we add them together, the result is positive. So that means of those two original numbers, the positive and the negative, the positive has to be more powerful. So we're looking for something like 16 and -1 as opposed to -16 and 1. In fact, there it is, 16 and -1. The product is -16. The sum is 15. So 4b squared plus 16bc minus 1bc minus 4c squared. Don't forget when you split that middle term that both those new terms have bc, not just the b or just the c. And again, technically I don't need to put that 1 there, but it came from right here. Okay, so factoring by grouping, greatest common factor of the first two terms, 4b, leftovers b plus 4c, leftovers b plus 4c, and I need a minus c outside to make it work. So now I've got b plus 4c times 4b minus c. Let's check our work. B times 4b is 4b squared. B times minus c is minus bc. 4c times 4b is 16bc. And that's when you think I was born, right? 16 BC, sorry. And 4c times -c is minus 4c squared. Combining like terms, 4b squared plus 15bc minus 4c squared, and it checks. Alrighty, let's take a look at this one. 16r minus 40r squared plus 25r cubed. Well, the first thing that I see is that it's not in standard form or descending powers. So I'm going to rearrange it. 25r cubed minus 40r squared plus 16r. Now it's in standard form. And let's see, is there a greatest common factor? Well, in terms of the coefficients, it doesn't look like it, but I could take an r out of each term. So we'll factor out an r, which gives me 25r squared minus 40r plus 16. It's finally warming up down here. Okay. So now I'm no longer considering the one above it. I'm just looking at the stuff in parentheses now to work on what's going to happen next. A is going to be 25, B is going to be -40, and C is going to be 16. Let's see. 25 times 16 would be 400, and then the sum is -40. I'm running out of room. I'm going to take that and I'm going to recopy it up here where I have more room to work. So two numbers whose product is positive, they've got to both be positive or both be negative. But the sum is negative, so they've got to be negative. So we're looking for two numbers that are both negative. Now, the answer is -20 and -20. I can see that. Maybe you can, maybe you can't. Let's say you don't see it. What do you do? Well, you could start with -400 and -1. Say, well, that gives you a sum of -401. That's not right. Well, we could cut this one in half and consequently double that one. and we'd still have a product of 400. Well, that would be negative 202. I'm still a long ways from the finish line, but at least I'm getting closer. Well, I could cut that in half and double that. That gives me negative 104. Cut that in half and double that. That gives me negative 58. Cut that in half and double that. That gives me negative 41. So you see what I'm doing there? Cutting in half, doubling, cutting in half, doubling. I'm getting closer, but I'm still not getting to negative 40. But can you see a pattern here? And again, this is sort of the deer in the headlight approach. Like, I didn't see that it was negative 20 and negative 20, so I'm going to kind of narrow it down. Well, these are getting closer to 0, and these are getting further away, right? So I need a number that's, I'm going to say, whose absolute value is smaller than negative 25, and one who's larger than negative 16. So what's between negative 25 and negative 16 that goes into 400 evenly? Well, negative 24 doesn't, 23, oh, eventually you're going to come up with, oh, negative 20. Oh, and there we have it. Now that's kind of a long way to go, but some of us may need that. Like I said, if you can't just look at it and say, oh, negative 20 and negative 20. Some of us will, some of us won't. So there's our two numbers, all right? So now what are we going to do? We're going to bring down the r, and we're going to rewrite the stuff in parentheses as 25r squared minus 20r minus 20r plus 16. And I switched from parentheses to brackets because in the next step, I'm going to have another set of parentheses when I use grouping. So this is going to be r. And splitting it, I'm going to get, let's see, 5r minus 4, 5r minus 4, and a minus 4 on the inside. So now I get r times 5r minus 4, and that's from this. Oh, and look at that. We also get 5r minus 4 from this and this. I could also write that answer as r times the quantity 5r minus 4 squared because of the two identical factors. So this answer would be correct, as would that answer. Which one's better? At this point, it doesn't matter. Later on, when we're doing some other things, one will be better than the other in a certain context. We'll talk about it when it comes up. Okay? Any questions there? Okay. I always wonder if, everybody's just gone to sleep, or maybe you've gone off to do something else because I can't see you or hear you, but, I'm just here alone. It's all right. Okay, let's see here. 10u squared minus 13u minus 6. Okay. This is in standard form of u. There's no greatest common factor. It doesn't have a leading coefficient of a 1 or of a negative. So we're just going to go to the ABC. A is 10, B is negative 13, C is negative 6. The product is negative 60, and the sum is negative 13. Well, let's see. If the product is negative, I've got to have a positive and a negative, right? But the sum is negative, which means my negative number has to be bigger than my positive. Again, I think I'm going to write this over here so I have more room to work with. So I've got to have a big negative and a little positive so that when I add them, I get a negative final answer. So I'm going to start with negative 60 and positive 1. I could start with 60 and negative 1, but remember the negative number has to be bigger. Well, that's not going to give me what I want. That's negative 59 as a sum. Let's cut this in half. Negative 30 and double that. We still get negative 60 as a product. Now our sum is negative 28. Oh, we're getting warmer. Well, let's cut this in half and double that. We get negative 11. Oh, I've gone too far. I've been accused of that before. He's gone too far this time. This number is right in between there, isn't it? So that means the two numbers I'm looking for, one of them has to be between -30 and -15, and one of them has to be between 2 and 4. Well, there's a bunch of numbers between -30 and -15, but there's only one between 2 and 4, and that's what, 3? So this would be 3 and -20, which would give us -17. So I narrowed it down. I knew it had to be between here. The only possibility doesn't work. Conclusion? Anybody?
Is it prime?
It's prime. Good. Now, be careful. A common mistake is for a student to have a problem, and rather than having some system of narrowing it down, they just randomly try stuff, and they try 2 or 3 and none of them work, so they conclude it's prime, which may not be true. I could conclude it's prime because I narrowed it down to where it had to be in between there, and that was the only possibility. Okay, so be careful with that. Like I say, a lot of times I'll get students that'll say something's prime when it isn't, because they've tried a few and just kind of randomly picked them. Okay. Let's see here. -28 u cubed v cubed. I love it when my voice corrects. Plus 26 u squared v to the 4th power minus 6 u v to the 5th power. Okay, so this is a trinomial. It's in standard form if you focus on u as the leading variable, because it's got u cubed, u squared, u. It's not in standard form in terms of v. We could turn the whole thing around, but if it ain't broke, don't fix it. It's in standard form in terms of u, so let's go with it. Now, greatest common factor. Well, the coefficients, I could take a 2 out. Oh, but the leading term's negative, so I would take out a -2. I can also take a u out of each term and a v cubed. So there's my greatest common factor. So I'm going to take that out of each term. So now my leftovers are 14 u squared minus 13 u v plus 3 v squared. Let's check here. Let's see, that's -28 u cubed v cubed plus 26 u squared v to the 4th minus 6 u v to the 5th. Okay, looking good so far. All right, now what's inside? There's a trinomial, standard form in terms of u. No greatest common factor, I've already taken that out. Leading term is not a 1 and it's not negative, so A, B, C, P, S. Here we go. A is 14. That's an A. It looks like a 9, but it's really not. Okay. B is -13 and C is 3. Now again, it's careful. We're not looking at these anymore. We're looking here at those numbers, right? Okay. Product is 42 and the sum is -13. A positive product has to have 2 positive factors or 2 negative factors, but the sum is negative, so it has to be 2 negative factors. What comes to mind? What times what is 42? What's the first thing you should think of? What times what is 42? Nobody knows? Come on. 6 and 7, but they're going to be negative. So -6 and -7, there's our 2 numbers. All right, good for you. So now I've got -2 u v cubed times 14 u squared minus 6 u v minus 7 u v plus 3 v squared. one of the biggest mistakes students make is they forget to bring down that greatest common factor. At the bottom of the problem, everything has to be there. So if you multiplied it all back together, you'd get what you started with. Okay, so don't let this go by the wayside. All right, so now factoring by grouping. Let's see, I'm going to get what? 2u, 7u minus 3v. So this is going to be 7u minus 3v. And I'm going to take out a minus v. Does that work? Let's see, that gives me minus 7uv plus 3v squared. Yep, that works. So now I've got negative 2u v cubed. I'm going to take out the 7u minus 3v and the 2u minus v. And there's our final answer. Okay. Now they're going to just mix it up because we've looked at section 6.1, 6.2, and 6.3. So let's just take some problems and see what we need to apply. So here we've got negative b squared minus 5b plus 24. This is a trinomial. It's in standard form, but it has a leading coefficient of a -1. So I'm going to factor out that negative and get that. Okay. Oh, it has a leading coefficient of a 1. So I don't have to use this grouping method. I can go back to 6.2 and split it up, a b and a b. The product is going to be what? -24, and the sum is going to be 5. Product is negative, one positive, one negative. The sum is positive. How about 8 and -3? Okay. Now, I could use the grouping method on this one, but that takes way longer, and I don't need to because the leading coefficient is a 1. So don't use it unless you need to, okay? Because that would be a much longer process. Okay. Next problem. 9x to the 4th plus 27x to the 6th. This is not a trinomial, so I can't use the techniques in 6.2 or 6.3. It's not really in standard form either, is it? But what's the greatest common factor here? It would be 9x to the 4th, so we'd have 1 plus 3x squared. Now, this is correct. You could also rewrite it as 27x to the 6th plus 9x to the 4th, and then 9x to the 4th times 3x squared plus 1. Both of those would be correct answers, okay? Because here and here, addition's commutative, so inside there, same result. Okay, let's see here. You good to go on? Yeah, okay. X cubed minus x squared plus 2x minus 2. Well, this is not a trinomial. It's got 4 terms. I guess that would be a quadrinomial, okay? It's in standard form. There's no greatest common factor, but what do we typically do with 4 terms? We use factoring by grouping. Let's see. The first 2 terms, we'll take out an x squared and have an x minus 1. So we should have an x minus 1 out of the second 2 terms. We have a plus 2. That works. So we get x minus 1 times x squared plus 2. So that was factoring by grouping. Let's see here. Next one. 4y squared plus 36y plus 72. Well, this is a trinomial in standard form. It has a greatest common factor of a 4. And let's see, that's going to be what, 18? When we take out the 4, the trinomial that's left inside has a leading coefficient of a 1. So we don't have to use grouping. We can go back and split it up like this and say, well, the product is going to be 18 and the sum is going to be 9. Let's see. Oh, 6 and 3. So there we go for that one. Let's see what else we've got. Okay. 3t squared plus 7 minus 10t. What are we going to need to do with this one, first of all? Anybody?
Put in standard form.
Awesome. Good job. 3t squared minus 10t plus 7. So now we have a trinomial. There's no greatest common factor. The leading coefficient is other than a 1, and it's not negative. So we're going to use the grouping method. A is 3, B is negative 10, C is 7, the product is 21, and the sum is negative 10. Well, I've got a positive product, so I've got to have 2 positive factors or 2 negative factors. But since the sum is negative, I've got to have 2 negative factors. Well, negative 21.
3 and negative 7.
There you go, negative 3 and negative 7. Good. Yeah. And like I say, if you can jump right to the finish line, you don't need to write other stuff down. But if you can't, it helps you have a pathway, so to speak. So I've got 3t squared minus 3t minus 7t plus 7. Grouping. Greatest common factor of the first 2 terms, 3t, t minus 1 left over. So t minus 1 has to be on the second group. And we're going to take out a minus 7. So t minus 1, 3t minus 7. And there you have it. And let's see here. Trying to look at. Okay. Let's look at one more here. 2u squared plus 3u plus 25. So this is a trinomial in standard form. No greatest common factor. Leading coefficient is not a 1. There's no negative to factor out. So A is 2, B is 3, C is 25. The product is 75 and the sum is 3. Whoops, wrong. The product is what? It's 50. A times C. I was distracted and something popped up on my phone and I looked over and distracted. Okay. So product is 50 and the sum is 3. This is what I know. The 2 numbers would have to both be positive, because if you had 2 negative numbers giving you a product of 50 and you added those 2 negative numbers, you wouldn't get a positive sum. So I'm looking for 2 positive numbers whose product is 50 and whose sum is 3. Well, let's start at the outside. 50 and 1. That has a product of 50, but that would have a sum of 51, right? Well, 50 is even, so I'm going to cut it in half and then double the 1. 25 times 2 is 50. That would give me a sum of 27. I'm getting warmer. 25 isn't even, so I can't cut it in half, but I could take a 5 out of it. So if I divide 25 by 5, I'd get 5. So then I'd multiply the 2 by 5 and get 10, which is 50. But you know what I'm going to do? I'm going to turn those around and write it this way. Oh, not 50, 15, so that I'm going down and going up. Okay. So I've got to have 2 numbers between 10 and 5 that go into 50. Does 9 go into 50 evenly? No.
No.
8?
No.
7?
No.
6?
So it's going to be a prime.
Prime, there you go. Good job. And I've gone through done all this trouble to narrow it down to say, okay, it's got to be in here and none of those in there work. So now I'm positive that it's prime. All right. Okay, well, I'm going to stop the recording.